Well, in this video today, I'm going to be talking about the Unit 1 summative review for Mrs. Gale's class. This is the first half of the review. Problem number 1. It says algebraically prove that the quantity x minus 1 times x minus 1 and the quantity 2 times x squared minus x squared plus 1 are equivalent. So the first thing we're going to do is we're going to simplify each of these expressions. First thing we do is multiply x times x, which is x squared. We multiply x times negative 1, which is negative 1x. Multiply negative 1 times x, which is negative 1x. And multiply negative 1 times negative 1, which is a positive 1. Then we're going to combine like terms. X squared minus 2x plus 1. So this is the first side, simplified. Now we're going to do the same thing to the other side. 2 times x squared is 2x squared. 2 times negative x is negative 2x. Then we bring down the negative x squared and the plus 1. And now all I'm going to do is combine like terms. So I have 2x squared minus x squared, which is 1x squared, minus 2x plus 1. As you can see, everything that is in this parenthesis matches everything that is in this parenthesis. Therefore, the answer would be yes. Okay. Number 2. Once again, we're going to simplify expressions. We're going to multiply 3x times 2x, which is 6x squared. We're going to multiply 3x times negative 5, which is negative 15x. Make sure you're watching your negative signs. Negative 2 times 2x is negative 4x. Negative 2 times negative 5 is a positive 10. All we're going to do now is combine like terms together. 6x squared minus 19x plus 10. You have now simplified this expression. And that's all you had to do. Problem number 3. Determine whether the two expressions are equivalent. Show your work to support your answer. We're going to do the same thing we did in number 1. So we're going to first start off by simplifying this aside. Okay? So that leaves me with a y squared, a minus 3y. We're going to multiply 5 times y, which is 5y. 5 times negative 3 is a negative 15. Watch out for your negative signs. And then we're going to combine like terms together. We have y squared plus 2y minus 15. Now we're going to simplify the right side. I have a y. I have another y. I have a 15. And I'm going to multiply these together to give me a y squared. And now I'm going to just combine like terms. So I have a y squared. I have a y plus y, which is 2y, plus 15. Okay. As you can see, everything in this parenthesis does not match what's in here. Okay. Why not? Because this is a no. Because one has a positive 15. And one has a negative 15. very important that you're watching those positive and negative signs. Okay, the next section we're going to be talking about is we're going to simplify, and then we're going to just decide whether it's linear, quadratic, or exponential. Remember, linear, the highest degree is 1. Quadratic, the highest degree is 2. And exponential has an x in the exponent. And if it's not one of those, we're going to just simply say none. So before we can make any decisions, we need to simplify. So I'm going to just rewrite it down here. F of n is equal to 7n minus 2 times n minus 1 minus 9. Now we're going to distribute. We're going to multiply 7n times n, which is 7n squared. We're going to multiply 7n times negative 1, which is negative 7n. Then we're going to multiply the negative 2 times n, which is a negative 2n. We're going to be watching negative 2 times negative 1, which is a positive 2. Make sure you're watching those negative signs. And last, we're just going to bring down that minus 9. Now we're going to combine like terms. So I have 7n squared. Negative 7 minus 2 is negative 9n. And 2 plus negative 9 is negative 7. Now, based on simplifying this expression, we can now identify which function family it's a part of. In this case, it's a quadratic. Because one simplified, the highest degree on x is 2. So that's a quadratic expression. Okay, problem number 6. For problem number 6, we're going to do the same thing we did as problem number 5. So I'm going to rewrite it again, just to give myself room to do my work. 5 times x squared minus 8x plus 7 minus another 5x squared plus 11. We're going to start off by distributing. 5 times x squared is 5x squared. 5 times negative 8x is negative 40x. 5 times 7 is 35. Bring down the negative 5x squared and bring down the positive 11. Now we're going to combine like terms. 5 minus 5, that means 0x squared. Negative 40x squared, negative 40x. And then we're going to combine 35 plus 11, which is 46. This is the simplified form of that expression. Now we have to decide which function family. In this case, it's going to be linear because one simplified. The highest degree on x is 1. Okay, so even though we had an x squared to begin with, once we combine like terms, the x squared just disappear. So it is not a quadratic, it is a linear function. Okay, now we're on the second page, number 7. Analyze the function f of x is equal to 4 times x minus 8 times x plus 12. This is factored form. And at the top of your review guide, we put there that factored form provides us with the x-intercepts and your concave up and down. So when we're going here, we're going to do our x-intercepts and our concave up or down. So to find our concave up or down, we're going to look at this first number. When this first number is positive, it's going to be concave up. And the x-intercepts are going to be the numbers that are inside these parentheses. And remember, when you take them out of the parentheses, they become their opposite. So the first x-intercept is going to be 8, 0. And the second x-intercept is going to be negative 10, 0. Remember, the x-intercepts are where this graph will hit or cross over the x-intercept, the x-axis. Okay, now we're looking at problem number 8. F of x is equal to negative 2 times x minus 8 squared plus 3. This right here is vertex form. And if you look at the top of your paper, in vertex form, you can find the vertex, the axis of symmetry, and the concave up or down. So when we get back to the problem, we're going to identify those key features. First thing it says is a concave up or down. Concave up or down is decided by the a value, which is the first number. In this case, it's negative, so it's going to be concave down. The vertex is going to be the h and the k. The h is located inside the parentheses. The k is at the end. Remember, whenever we take something out of parentheses, it becomes opposite. So the vertex is actually going to be a positive 8 and a positive 3. Now, the axis of symmetry is just x equals whatever h is. So since h is an 8, x is 8. That's your axis of symmetry. And last but not least, number 9. For number 9, we have the function f of x is equal to x squared minus 16x minus 1. Here we have standard form. Standard form, according to what we've been studying so far, tells us that we know the y-intercept from this form, and we know whether it's concave up or down. So that being said, we're going to go right to this. Is it going to be concave up or down? This first number right here is going to tell us that concave up or down, just the same as it does in every problem. Since it is positive, it's going to be concave up. And the y-intercept is the c value. The c value is located at the end of the problem. So in this case, your c value is going to be 0, negative 1. That will be your y-intercept. Okay, and the last problem we're going to do today right now is problem number 10. Which functions below could match the graphs on the right? Write the letter for each equation below, graph if any. So let's first look at them, okay? We know by these leading numbers whether it's concave up or concave down. For this first picture, we know it's concave up. So we're really only looking at letters A and letter B because C and D would not be concave up. So if we look at letter A, this is going to be a vertex form. So in this case, the vertex would be +1, +2. And for letter B, the vertex would be a -5 and a -3. Well, if I was to graph either one of these 2 points, the only point that could possibly be in the correct quadrant would be +1, +2, because that could possibly be this point right here. So for the first graph, letter A would be our choice. Okay, now let's go to the second graph. Once again, we want to look at these numbers in the front to determine which graphs we're looking at. In this case, it's concave down. So the only ones that we really want to focus on are going to be letters C and D, because A and B would be the wrong direction. Well, letter C, the vertex, would be a +3 and a -2. And the vertex for the fourth one, letter D, would be a -3 and a +2. Well, if I was to graph those points, if I went to +3, -2, I'd be somewhere over here. If I was to graph -3, +2, I'd be somewhere over here. Well, neither one of those are in the same region as my graph, so this would simply be none. This is the first half of your summative review.